For most of human history, building literally anything taller than ourselves meant fighting this really grueling sheer muscle war against gravity.
Oh, absolutely. It was all brute force.
Right. I mean, you hauled stones up these massive dirt ramps, or you build those sprawling, wobbly wooden towers just to reach a ceiling or lay a high row of bricks. And honestly,
Ex-
when you look at a modern construction site today and see that massive wall of metal scaffolding, it still feels, I don't know, a bit primitive.
Yeah, it really does. I mean, it's essentially this static manual solution to a very dynamic physical problem.
Exactly.
And we often kind of overlook the hidden costs there because it is just incredibly labor intensive to create the conditions necessary to do the actual work.
Oh, yeah, setting the stage, basically.
Right. A crew can spend days assembling pipes and planks, basically engineering a temporary structure before, a single paintbrush or wrench is ever actually used on the building itself.
Which is actually the perfect entry point for the stack of sources sitting on the table for us today. Today is Saturday, August 8, 2026, and we are looking at this really fascinating combination of internal briefing docs, some strategic asset plans, and a brand new corporate press release.
Yeah, from Empower Rental Group, right?
Yep, widely known as ERG. And the overarching mission for today's deep dive is to explore how something that sounds, as purely industrial as boom lift rentals is actually fundamentally reshaping construction economics.
It really is a masterclass in strategic asset management.
It totally is.
Mm.
So whether you are managing a complex build, maybe analyzing industrial markets, or if you're just someone who's fascinated by the mechanical realities of how our physical world gets constructed, we are going to look at how businesses solve these complex physical problems. Basically treating elevation as a highly engineered technical skill rather than a physical struggle.
Right, moving away from the brute force approach.
That's exactly. Okay, let's unpack this. Because the sources make a really compelling case that traditional access methods are just failing modern project timelines. So what is the fundamental mechanism driving this shift away from scaffolding and toward, modern hydraulic access?
Well, the primary driver is really the elimination of what they call the operational bottleneck. Because in any project, time is, it's your most constrained resource.
Always. Time is money.
Exactly. And when you rely on scaffolding, you aren't just paying for the materials. You're paying for the massive labor hours required just for the setup, plus the downtime when it inevitably needs to be repositioned and, the huge liability of workers navigating this static structure.
Right. Climbing up and down all day.
Yeah. So modern boom lifts rewrite this whole equation through the mechanics of fluid dynamics. Fundamentally, a boom lift is this highly sophisticated aerial work platform, and it's divided into three distinct anatomical sections.
Okay, what are the three?
You have a massive counterweighted base, a hydraulic arm, and then the operator platform or the basket.
And the magic really happens in that hydraulic arm, right? Because we aren't using gears and pulleys to hoist people into the air anymore.
Right, exactly. The arm relies entirely on pressurized hydraulic fluid. And because liquid is virtually incompressible...
Wait, incompressible meaning it doesn't squish down when you squeeze it?
Exactly. So when a pump at the base applies pressure to the fluid, that exact force is transmitted instantly to the cylinders in the arm. So this allows a massive steel structure to lift hundreds of pounds of human beings and heavy tools with this incredible smoothness.
Oh, wow. So no jerky movements.
Right. The operator in the basket is actually controlling these tiny valves that regulate the fluid flow, so they can make these microscopic adjustments to their position in three-dimensional space.
That's wild. So using scaffolding today is sort of like building a temporary staircase every time you need to change a light bulb, whereas a boom lift is like having this personalized hydraulic jetpack that you control directly from the basket. Is that why the sources refer to this as access on demand?
That's a great analogy, actually. And yes, access on demand implies this complete eradication of setup time. The operator arrives, they run their safety checks, step into the platform, and they're at the work site maybe 80 feet in the air within minutes.
That's a massive shift. You're converting brute manual labor into precision execution.
Exactly. But, getting off the ground is really only the first part of the physics equation here.
Right, because once you're up in the air, you actually have to navigate to the exact spot on the building. Having a massive hydraulic arm doesn't really mean much if the airspace is completely cluttered.
Oh, absolutely. The sky above, say, an open highway project is vastly different from the sky above a dense residential neighborhood.
Yeah, for sure.
So the working envelope, which is the physical space the machine can safely reach, is entirely dictated by its geometry. The sources highlight that the most powerful machine in the world is totally useless if its structural geometry clashes with the environment.
Okay, so shape matters just as much as power.
Precisely. And this leads us to the two primary designs we see in the industry: articulating booms and telescopic booms.
Let's break those down. What's an articulating boom?
So articulating booms are engineered with multiple hinge points. They literally bend or they knuckle in several places along the arm.
Oh, kind of similar to how a human arm has a shoulder, an elbow, and a wrist to reach around an obstacle.
That is the exact mechanical principle, yeah. And this design is absolutely crucial for what the industry calls up and over clearance.
Up and over. Okay, give me an example of where you'd need that.
Let's say a contractor is working in the dense urban architecture of St. Matthews, right? They aren't just going straight up. They have to navigate over roof lines, weave through dense mature tree canopies, or reach across tight alleyways without the base of the machine blocking traffic.
Right, because there are cars and pedestrians everywhere.
Exactly. So the articulating knuckles allow the operator to fold and unfold the arm to trace those really complex architectural lines.
Okay, that makes sense. Which leads me to deduce that if articulating arms are built for those complex, cluttered environments, the telescopic boom must be designed for just raw, unobstructed distance.
You nailed it. Telescopic booms are fundamentally simpler in their geometry, but they are just massive in their scale. They consist of these straight, tubular steel sections that basically nest inside one another.
Like a Pyrus telescope.
Exactly like that. They slide out on wear pads, extending in a completely straight line. They don't bend at all. They just shoot straight out and up.
So they just go for maximum vertical and horizontal reach.
Yes. They are the absolute benchmark for open field telecommunications towers, maybe bridge inspections, or high voltage utility lines.
Here's where it gets really interesting, though, because it sounds like procuring the most powerful piece of equipment, say the telescopic one, is actually a rookie mistake. It's a massive liability if it's the wrong shape for the airspace.
Oh, 100%. It happens more than you'd think.
Like, if a property manager in St. Matthews rents a 120-foot telescopic boom to fix a roof in a really crowded cul-de-sac, it's like bringing a high-speed dragster to a grocery store parking lot. You have immense power, but absolutely zero turning radius.
That is a perfect way to put it. And the briefing documents actually refer to that exact scenario as creating a dead zone.
A dead zone. What does that mean in this context?
Well, the target area on the roof might be completely visible to the operator from the ground, but mathematically it's unreachable because the straight arm of the telescopic boom physically cannot bend over the neighbor's garage to get the basket to the shingles.
Oh, wow. So you can see it, but you just can't touch it.
Right. The geometry of the machine mandates a direct line of sight. When you select the wrong geometry, you experience what they call complete site access failure. So you're paying these massive daily rental rates for a monolithic piece of steel that literally cannot perform the job.
That sounds like an expensive mistake. And while the operator is up there trying to solve this complex airspace problem, they are completely dependent on the physics of the ground below them, right? Because to push 100 feet into the sky and bend around a roof line, you have to be creating incredible leverage and torque down at the base.
Oh, absolutely. The mechanical realities of the boom arm are entirely secondary to the stability of the base. If the base isn't secure, the whole thing fails.
Because the base isn't just a car that drives the arm around.
No, not at all. It is the physical anchor. It houses this incredibly heavy engine and these massive steel plates that act as a counterweight. That counterweight is the only thing preventing the entire apparatus from tipping over when that arm is fully extended with, two workers and all their gear in the basket.
Right. But that counterweight relies entirely on the ground's ability to, push back and hold it up.
Exactly. And the sources focus really heavily on these ground-level variables. They actually use the Ohio River Valley as a prime case study for this.
The Ohio River Valley, because of the weather.
The weather, yes, but mostly the notoriously volatile geological profile of that area. I mean, you have areas of solid limestone, sure, but you also have these vast stretches of uncompacted soil, heavy clay, and really tricky slopes.
Yeah, and a sudden rainstorm there can instantly turn a pristine construction site into just dense, immobilizing marsh and muck.
Exactly. It turns to soup. So to combat this, the industry relies on three distinct types of locomotion. First up, you have standard tires.
Like heavy-duty truck tires.
Pretty much. These are the most common, and they're designed specifically for stable, improved ground. Think fully paved parking lots or poured concrete slabs.
Right, because standard tires exert a massive amount of PSI pounds per square inch on a very small contact patch.
Mm.
So on concrete, that's fine. But in mud, they just drill themselves into a hole.
Exactly. They just spin and sink, which necessitates the second option, which is treads.
Similar to what you'd see on a military tank.
It's exactly like a tank. Treads solve the PSI problem by drastically increasing the surface area that's in contact with the ground. So they distribute the massive weight of that counterweighted base over a much larger footprint.
Ah, so you don't sink.
Right. This is absolutely non-negotiable for sites with loose gravel, sand, or uneven slopes. Because when you're working on a gradient, maintaining traction is literally the only way to maintain the machine's precise center of gravity.
Okay, so tires for concrete, treads for slopes and loose dirt. What about for the truly terrible terrain, when it's basically a swamp?
For that, you need the third option, which involves extreme modifications like crawler legs. When a site in the Ohio River Valley turns to absolute soup, a wheeled machine would sink to its axles. The documents call that catastrophic downtime.
Catastrophic downtime. Sounds expensive.
Very. So crawler legs, which are often combined with specialized outriggers, they allow the machine to literally stride or dynamically stabilize itself over terrain that would just swallow standard equipment whole.
Okay, but let me challenge the operational logic here for a second. I totally understand the physics of ground pressure and the risk of that clay turning to soup.
Mm-hmm.
But if crawler legs and treads are so secure, why wouldn't a contractor just mandate treads or crawlers for every outdoor job? Like just to hedge their bets against unpredictable weather to be safe.
What's fascinating here is that over-engineering the base actually introduces its own set of operational failures.
Really? How so?
Well, treads and crawlers are extremely heavy, they're very slow, and they are mechanically complex. So if you mandate treads for a project that takes place primarily on an asphalt parking lot, those steel or heavy rubber tracks will literally chew up and destroy the finished surface every single time the machine turns.
Oh, wow. I didn't even think about them destroying the site itself.
Yeah, it's a huge issue. Furthermore, treaded machines are significantly more expensive to transport to the site, and they cost far more to rent.
So defaulting to the most extreme terrain option just burns through your project budget and ruins your paid services?
Exactly. It is a major economic and operational misstep. The true objective here is to calculate the exact soil density, the gradient of the site, and the surface material ahead of time. Then you procure the specific locomotion that guarantees stability without sacrificing your mobility or blowing up your budget.
Which naturally brings us to the immense financial puzzle of this entire industry, right? Because we've established that a project manager needs to precisely match the geometry of the arm articulating or telescopic to the airspace. And then they have to match the locomotion tires, treads, or crawlers to the soil density.
Right, it's a very specific matrix.
So that means over the lifespan of a single commercial build, a company might legitimately need 6 different machine configurations at different phases.
Oh, easily, yes.
Now, obviously, heavy machinery depreciates. And total cost of ownership, or TCO, is a very well-known variable in construction. But surely these massive construction conglomerates eventually hit an economy of scale, where buying a fleet of these lifts outright just beats paying rental margins indefinitely, right? Why do the strategic plans in our sources so heavily favor the rental model?
Because that concept of economy of scale breaks down entirely when you factor in utilization rates and liability.
Utilization rates, like how often it's actually being used.
Exactly. If a conglomerate purchases a massive articulating crawler for a specific phase of, say, a 2-year project, that machine might only be actively required for 45 days out of the whole build.
Oh, wow, just 45 days.
Right. So for the remaining 22 months, that asset is just sitting in a yard. But it is still depreciating. It still requires highly secure, expensive industrial storage space. And crucially, it still mandates rigorous, federally mandated OSHA maintenance schedules.
Even if it's just sitting there.
Yes. Heavy lifting equipment requires constant non-destructive testing for microfractures, hydraulic fluid flushes, sensor calibrations, all of it.
Ah, so it's the hidden costs of compliance. A machine is literally bleeding capital while sitting entirely idle.
Exactly. So the rental model, as outlined in the sources, fundamentally alters a company's balance sheet. It converts these massive fixed capital expenditures, buying a depreciating asset, into variable, tightly controlled project costs. So a business preserves its liquid capital, deploying it only when a specific machine configuration is actively generating revenue on the work site.
It's the exact same logic driving modern cloud computing for physical hardware. Like 10
Mm.
years ago, tech companies built these huge, expensive data centers that just sat half empty just in case they needed a traffic spike. Now they just rent server space from AWS or Google.
Yes, exactly.
You get the exact technical redundancy you need right when you need it without the liability of ownership. Here, a contractor spins up a 60-foot articulating lift on standard tires for the drywall phase, spins it down, and then spins up a telescopic crawler for the exterior utility work.
That is a perfect framework for understanding Empower Rental Group's overarching strategy. ERG realized that to be the cloud provider for physical machinery, they needed massive scale. But construction is deeply localized. Contractors rely heavily on local relationships and trust.
Right, you want to know the guy you're renting from.
Exactly. And this is exactly why ERG acquired Right Way Equipment. They basically engineered what they call a local national hybrid model.
Oh, so they buy the trusted local yard, they keep the signage and the people, but then they plug them into this massive national supply chain.
You've got it. They maintain the boots-on-the-ground knowledge of the local soil and the local architecture, but they inject the redundancy of a massive national fleet. So a local contractor in Kentucky isn't limited to just whatever machinery happens to be sitting on the local lot that Tuesday.
They can get anything they need.
Right. They suddenly have guaranteed rapid access to highly specific variations of boom lifts, along with, telehandlers, mini excavators, forklifts.
Which perfectly brings us to the breaking news from the sources today, August 8th, 2026. ERG is actively deploying this hybrid strategy by officially expanding its boom lift services deeply into the St. Matthews market today.
Yes, it's a huge move for them.
But what immediately caught my attention in the press release is how much space they dedicate to talking about contractor education.
Hmm.
It reads more like a school curriculum than a corporate sales pitch. Why is an equipment rental company spending so much capital teaching their clients how to do their jobs?
Because in the high-stakes environment of heavy machinery, client education is actually the ultimate form of asset protection and risk mitigation. ERG's corporate culture operates on 5 core pillars: safety, care, responsiveness, strong relationships, and teamwork.
Okay, so it's a culture thing.
It is. I mean, think about it. Handing over the keys to a machine capable of lifting someone 8 stories into the air without strictly verifying that they understand the physics of ground pressure and the geometry of the airspace, that is an immense liability.
Yeah, because if the base of a boom lift shifts just 1 inch in the mud down on the ground, the pendulum effect means the basket 80 feet in the air might violently swing 2 or 3 feet,
Right.
potentially throwing the operator.
That is exactly the kind of physics ERG wants their clients to understand before they even power on the engine. The briefing documents present this really profound realization. We have loaded these machines with tilt sensors, auto-locking brakes, hydraulic limiters.
All the bells and whistles.
Right. But those mechanical safety features are ultimately secondary. An educated operator, someone who actually understands how to evaluate terrain variables and select the correct geometry, that person is the most effective safety device on the machine.
Wow. So what does this all mean for the listener? If you are analyzing industrial business models or trying to optimize a project's logistics, what is the core strategic takeaway from how ERG operates here?
If we connect this to the bigger picture, it really highlights the vast difference between an equipment warehouse and a strategic operational partner.
A warehouse just wants to rent you stuff.
Right. A warehouse views success as just getting the most expensive piece of iron off their lot and onto your invoice. But a strategic partner like ERG understands that the machinery is just the vehicle, empowering the user to make highly engineered decisions, helping them perfectly match the lift to the architectural and geological realities of their specific site. That is the actual product.
That makes total sense.
Because that education is what prevents catastrophic downtime, it mitigates financial liability, and most importantly, it ensures that every single worker comes down safely at the end of the shift.
It completely reframes how we view the physical maintenance of our world. I mean, the shift from dragging ladders and bolting together scaffolding to deploying this specialized hydraulic access. It transforms manual labor into a highly calculated technical discipline.
It really does. It elevates the whole industry.
Literally and figuratively.
Hmm.
And for anyone currently staring down the complexities of a commercial build, whether you are, navigating the dense architectural grid of St. Matthews or trying to conquer the unpredictable, shifting terrain of the Ohio River Valley, these operational solutions are readily accessible.
Absolutely.
ERG's main regional hub is located at 4705 Robards Lane in Louisville. Their local experts are available Monday through Friday, 7:00 a.m. to 4:30 p.m. You can reach their team directly at 502-458-3261, or you could explore their entire national fleet inventory through their digital hub at renterg.com.
And honestly, having access to that level of hyper-local terrain knowledge, backed by the sheer physical redundancy of a national fleet, that is a massive operational advantage for any project manager.
It changes the entire timeline of a build. Well, as we close out today's deep dive, I want to leave you, the listener, with a final thought to just mull over. We started today talking about our historical struggle against gravity, right? Building massive, static towers just to lay a brick.
Right.
Today, we conquer gravity with pressurized fluids and articulating steel joints. But looking forward, the challenge isn't just about reaching higher. It's about navigating increasingly complex, confined spaces. As our cities undergo massive urban infill, as streets get narrower and architectural renovations become more intricate, the airspace we work in is only getting tighter.
Yeah, space is at a premium.
Exactly. So how will the shrinking physical footprint of tomorrow's urban architecture dictate the engineering of the machinery we use to maintain it? Will our tools have to become even more jointed, perhaps evolving into localized microbooms or spider lifts, just to keep our densifying cities functioning?
That's a great question. Because the constraints of our environment will always force the next evolution of our engineering.
Something to consider the next time you see a machine silently knuckling up and over a roofline in your neighborhood. Thank you for joining us on this deep dive into the fluid dynamics of elevation, the physics of ground terrain, and the strategic logic behind modern access. Stay safe out there, keep looking up, and we will catch you on the next deep dive.